Hey, I'm doing something a little different today. We have an integral from the UNSW 2021 Integration Bee, problem number 2. UNSW stands for University of New South Wales in Australia. Okay, so we have this integral from 0 to 2 pi, x minus pi cubed cosine x dx. And right off the bat, I'm going to say this right here, this x minus pi is a little bit awkward and I want to do something with that. So I think we're going to do a u substitution. But instead of making my u x minus pi, what I'm going to do is just a little different. I'm going to call my u pi minus x. And the reason I want to do that is because I know we have a supplementary angle formula for cosine x. We could do it the other way, but I think it's just a little bit nicer this way. So if we do u equals pi minus x, then x is going to be pi minus u. dx is going to be, derivative of pi is 0. Derivative of minus u is just going to be a minus du. And then let's just make this substitution and see how it goes. So first we'll plug in 2 pi in here. So pi minus 2 pi is minus pi. We'll plug in a 0 in here. Pi minus 0, pi. Then here for x minus pi, we're going to have a minus u because we flipped the sign here, but that's cubed. Then for cosine x, we're going to have cosine pi minus u. Like I mentioned earlier, that's going to be a supplementary angle formula, which we'll go over in a second. And then for our dx, we're going to have minus du. And then I think before I go further, what we're going to do is we're just going to take this minus sign and use it to flip the integral. So we'll change this to a plus, and then we'll change that to a plus, and we'll change that to a minus, just flipping it with that change of sign. Then next, for that supplementary angle formula that I mentioned before, I don't know if I said complementary, it's supplementary angle. We just have, this is exactly what we have here. In this case, we're going to have minus cosine u. So anyway, what we'll do is we'll make use of this and we'll rewrite our integral. So we're going to have, this is going to be pi to minus pi. We can just write this minus u all cubed. We can just write this as minus u cubed. And then for cosine pi minus u, we have this. So it's going to be minus cosine of u du. But we have minus times minus. This is just going to be pluses. Those will cancel out. And here we're really close to a solution, but let's just go over one other thing before we get to integrating this. Okay, so what we have over here on the right is we have this really useful property in contest integrals, which tells us that if we have an odd function, f of x, and our bounds are minus a to a, whatever a is, then this whole integral is 0. And we have that here, right? Because we just have pi and minus pi. And then so our only task is just to show that this function, this here is odd. If this is odd, then our integral is going to be 0. Now we don't have a lot of work to do to show that this is odd, just because u cubed is like the classic odd function that you learn right away, and cosine is one of the first functions that we learn is even. An odd function times an even function is always odd. But let's just show this really quick for this example. So we have here our definition of an odd function that says if we input negative u value and we get back minus the function, the original function, then this is an odd function. So we have, this will be our f of u, this whole thing here. And then what we'll just do is we're going to plug in a minus u. So we're going to have minus u cubed times cosine minus u. But we know, like what we did earlier here, is that minus u cubed is just minus u cubed. We can remove the parentheses. And then we're going to assume we know that cosine is an even function, so this is just cosine of u. But we could actually kind of put a parenthesis here, and then that's just showing that this whole thing is minus f of u. That's what we wanted to show here. So this is an odd function, and so our answer is going to be just 0. That's a big 0. Thought it was a good problem. Thank you everyone for watching. Please like and subscribe. Have a great day.